Hello and welcome to another Physical Sciences 3 lecture. In the last lecture we looked at mass spectrometry. I always struggle with that word. And we can use mass spectrometry to find the average mass number, which we'll look at now. So a naturally occurring element is a mixture of all of its isotopes. Okay, so if we gather all the isotopes of a different element, we can find out what its average mass number is by weighing those individual isotopes. Um, okay, so naturally occurring chlorine consists of 75.8% of chlorine 35 and 24.2% of chlorine 37. So just to make sure we're all on the same page, chlorine, remember chlorine has 17 protons, then this will be 35 Cl like this, and this will be 1737 Cl. So we can see from this that they look like CC, doesn't it? CC, CL. Let me make that nicer. Okay, yeah. Let me try and get my C's a bit better and L's. So C, L, and C, L. Okay, so that's how we would do our symbols from before. So naturally, 75.8% of them are these chlorine 35s, and 24.2% of them are chlorine 37s. And see, they have the mass number of 37 and 35 respectively. Note that in the previous example, the percentages were simplified to make it easier to draw and label the mass spectrograph according to standard convention. Find the average mass number of the chlorine. So, okay, so if we have 75.8%, so remember that 75.8% is equal to 0.758, and so then we'll times that by 35, and then we'll go plus 0.242 times 37. Okay, and that's because, so I'll just write over here, 75.8% is equal to 75.8 divided by 100. Okay, so that gives you the decimal. And then if we put that into our calculator, I'll move it over so we can see. We go now main 0.758 times by 35, 26.53. I'm not sure why I didn't just add that 0. I should have just done it all in one line. I don't know why I didn't do that. Okay, so its average is 35.484. And that is in atomic mass units. Okay. So this example here, note that this question is taken from the 2015 external exam and adopted an easy approach to representing relative abundance on the mass spectrograph. The mass spectrum below shows the relative abundances of the three isotopes of a naturally occurring element. Okay, so first of all, we want to calculate the relative atomic mass of the element, and luckily they've put in what the values of all of the different percentages are. Okay, so the average, the relative atomic mass or the average mass is equal to 10%, so 0.10 times by 86, and then we have plus 0.07 times by 87, and finally we have 83%, so 0.83 times by 88, and that will be equal to, let me bring this to this side, 0.1 times 86 plus 0.07 times 87 plus 0.83 times 88. Good. And so that is 87.73 AMU. Okay, so that's the relative atomic mass for this element, and then using the answer, identify the element. Okay, so what you can do is you can find your formula sheet. If you've got an electronic copy, or you might have printed out. And what we want to do is find, what was it, 87.73 So we need to find 87.73, and it's the bigger of the two numbers. So let's find out, go down here, 87.73 was it? Let's have a look. I'm guessing it's going to have to be strontium then, isn't it? 87.73. So they've obviously rounded up the percentages. Okay, 87.73. So we haven't got the exact number. So it'll have to be 87.62 is our closest one. So it is going to be strontium. Strontium there. So element is strontium. Okay, element is strontium. Good. So that's one of the useful ways for using a mass spectrometry, and we'll leave it there when we're looking at formation of ions on the next lecture.